Okay, so we are looking at the quality control, the assignment review. Okay, so under this quality control, which is quality management, we are getting down to the first question of this paper. So the question one says you have been tasked to develop a control chart by a company, the Lean Manufacturing, that has started using statistical process control to improve how it manages its processes. Samples of 125 have been randomly selected during each shift or 25 shifts in production process at Lean Manufacturing. The data are given below. Then it says construct the control charts to be used to monitor this process. So the samples that we have samples from 1 through to 25. And of course, we have the number of defective items in each sample. So getting down to the samples here, we have sample 1 with a defective of 10, sample 2 with a defective of 14, sample 3 with 22, sample 4 with 17, sample 5 with 27, sample 6, 42, sample 7, 49, sample 8, 36, getting down to the sample is 25. So for this one, what is just important now here is to getting down to the solution. So in the solution here, we are just simply looking at the total, so meaning that here it will be 10 divided by 125. So the sum here, it was 125, so it's the sum of 125, which was indicated in the question. So the question here indicated the number of samples. The samples of 125 have been randomly selected during the each shift of 25 shifts in a production process at the Lean Manufacturing. So the data are given below. So construct the control charts to determine and to use to monitor this process. So getting down to the probabilities, the proportion is the sum is 125. So we are supposed to find the proportions of defective items. So here we are dividing 10 by 125, which is 0.08, 14 by 125, which is 0.112. And then 22 by 125 to 0.176. Getting down to each of these proportions. So these are the proportions that we found. Then from these proportions, we actually now looked at the proportion of probabilities of defective items. So these are the proportions. Now getting down to the final, the overall proportion, the summation of all these ones, the sum of each of these proportions that we have here to find the mean of the proportions. So we find the P bar, which is the mean for the proportions. So there is need to find the mean for each of these proportions, addition of each of these proportions, then you divide by the number, right? So this is just about what was going on here. So our P bar, we are getting the P bar is 0.23104. So this is what is going on here concerning finding the P bar. So now after this, we are supposed to develop the control limit. So for this one, for the P chart, so the control limit for the P chart, we are simply finding the lower control limit. This one is called lower control. So lower control limit. Then we are also supposed to find the upper control limit. So the formulas are given. Lower control limit is that one. Then upper control limit. Upper control limit, we say it's a P bar plus 3, which is a standardized, the square root of 1. Okay, so that is P bar. Then 1 minus P bar. Okay, over N. So this is on how we are getting down to find the upper control limit and then the lower control limit. Okay, so from here, after getting the upper control limit and the lower control limit, we need now to plot our P bar is the center line. So this one is our center line. And then getting down to the upper control limit we found from here, we have upper control limit. From here, our upper control limit is 0.34 and lower control limit 0.1179. Upper control limit is 0.34414. Then after graphing using the proportions from the table here, we have discovered that the process is not in control because we have other values that are outside boundary. So this one is outside. And of course, we have another one that is outside the boundary. These are outside boundaries after plotting. We have this other one, which is also outside. This point is also outside. This point is also outside, and you have all these points that are outside. So these points are outside the control limits. So we are simply saying this process is statistically not in control, all right, because they are above the control limits, the upper control limit, and of course, the lower control limit. So comment that the statistical process is not in control since the samples of 1, 7, 13, 20, 21, 24, and 25 provide that they are outside control limits. So that marks the end of question 1. Okay, so this is just about finding the proportions that we can get, dividing these proportions by 125. So this one divided by 125 to get the proportion. Even this one divided by 125. Even this one divided by 125 to get the proportion. This one divided by 125 to get the proportion. So here we are simply saying that the process is not in control because these values, they are outside the control limits. All right, so this is about what this one is actually mentioning. So we are simply saying the statistical process is not in control since the numbers 1, 7, 13, 20, 21, 24, 25 provide points that are outside control limits. Then getting down to question 2, of this assignment. The quality control, we have the cost of quality control. So there are 4 costs of quality control. Cost of quality. So there are only 4. Number 1, we have prevention cost. So we have prevention cost. Then number 2, we have the appraisal. Then number 3, we have internal failure. So we have internal failure. Then you have external failure cost. So these are the 4 costs of quality. So it's just a matter of understanding them in detail. Okay, then here we have a medical industry manufacturer of blood filtration products used in dialysis has to meet the rigid standards in the field, the product design, precision manufacturing equipment, then raw materials, component quality from suppliers and all, then product failure and the customer level is quite expensive. All right, and then they have the other information here where I simply say manufacturing costs on sales were 70,000 and 1 million respectively. The expenditure for the past year are shown in the table, and then analyze the various quality cost components. What proportion are they of the total quality costs? And find the total quality cost, okay, as a proportion of manufacturing costs, and we do a comment. Then should senior management stress less on design issues? Explain your position. So getting down to this one, the solution is that after analyzing these costs into 4 categories, 4 quality cost categories, we are simply saying we have those 4 costs. So meaning categorizing them, the prevention cost or calibration of test equipment, which was 10,000. These were in Kwacha. Then maintenance of ISO standard certification, which is 100,000. Operator training, which is 20,000. Planning for quality through quality improvement teams, which is 50,000. Review and update of the design, 200,000. So the total of the prevention cost, okay, came to 380,000. Then getting down to the appraisal cost, incoming raw material inspection, 30,000. In-house product testing, 40,000. Vendor selection, 20,000, which is giving us the total of actually 90,000. Then internal failure cost, we have the scrap cost of non-conforming products, which is 50,000. And then external failure cost, we have failure within warrant period, which is 100,000. Total manufacturing cost or quality cost of the total manufacturing cost or total quality cost now is a cost of this one, the 90,000, the 50,000, the 100,000 is 620,000. And then this one as a percentage, so meaning that we're dividing this one by 620,000. So we are presenting this one as a percentage, we are getting that. This one divided by 620,000, we are simply getting 14.5. This one divided by 620, we are actually getting the 8.1. This one by 620. Okay, so we are getting the 16.1%. All right, so meaning that the cost of review and update design is much higher, which is increasing the cost of prevention considerably. Okay, to obtain the optimal quality level, the total cost of failure, internal and external, should be equal to the prevention cost. So this is the review of this question 2. So these are the categories from the breakdown of the cost of quality that was given in the question. You are supposed to categorize these ones. Okay, so meaning the calibration of test equipment and the other cost of quality. So maintenance, the maintenance there is on the prevention cost. The training is on prevention, planning is on improvement, reviews are also on prevention cost. So getting down to this table, they need to, so this is prevention cost. Okay, then maintenance is prevention. The training is also prevention. Planning is also prevention. Review is also prevention. So all these will be aggregated as we get the prevention cost. Then getting down to appraisal. So appraisal is incoming in-house product testing, incoming inspection, product testing, vendor selection. So these ones are appraisal. All right, so from here, for appraisal, we are simply saying incoming inspection is appraisal. The product testing is also appraisal. The vendor selection is appraisal. So this is prevention, prevention, and then we have appraisal. Then the other ones, for concerning the other costs is the internal failure, the scrap of non-conforming products. The scrap of non-conforming products is the scrap of non-conforming products. This is internal failure. Internal failure. Then the remaining are those ones, they belong to this one is external failure cost. Failure within warranty period is external. So this one, these ones are prevention. Even this one, so this is appraisal. So this is just about, even this one is also appraisal. So this is just about what goes on when looking at this one here. All right, so this is concerning these costs. All right, the four quality cost categories. So this is how the breakdown came to this one. Okay, so we are getting down to interpretation. So the prevention cost was 61% of the total cost. The appraisal cost was 14% of the total cost. And the internal failure was 8% of the total cost, or the total percentage, so to speak. External failure was 16% of the total percentage. The cost of review and update design is much higher, which is increasing the cost of prevention considerably. Okay, so this is the end of question 2. Question 3 is actually talking about the specification of whatever we are doing. So you took a team of mechanics through the process of using control charts to determine the process capability. You apply studies to process that is in this control and output is normally distributed. The specification for the product processed are 28 plus or minus 2, okay, with the process mean of 28.6 and standard deviation of 0.53. Is the process capable? So to determine if the process is capable, we are first of all supposed to carry out the upper specification limit and the lower specification. So upper specification, we are supposed to add, we are getting 30. The lower specification, we are getting 26. Okay. So the process capability index is the minimum of upper specification minus the mean over the 3 sigma. So we get the minimum of those. So we are getting the X minus lower specification. There's a comma here over the 3 sigma. So meaning that the minimum of these two is 0.88 using the formulas. So this one is upper specification and the other one is the lower specification limit where you subtract. So from the above calculation, the process is not capable to meet specification since the CPK is less than 1, unless if it was equal to 1, it would have been. All right, so the minimum of those. And then the other thing to do now here is that proportion meeting specification. To find proportion of products meeting specifications, we use the process capability index, the CP, the CP is a process capability index, which is the upper specification minus lower specification over 6 sigma. So upper specification is 30, the lower specification is 26, then 6 multiplied by the standard deviation in the question was 0.53. So here we need to get the solution for this one. So we are simply saying that our process capability index is 1.258. Now the proportion meeting specifications is 1 minus 1 over CPK. So we are getting 38.3, so approximately 38.8 of the products will meet the specifications. 36.8% of the products will meet the specifications. So just using this process capability index, substituting it in this equation. So how do we improve the performance? The other question says, how can the performance be improved? So the proportion meeting specification is 36.8%. Then what adjustment would you make to the process to improve its performance without change of standard deviation? Okay, and with the adjusted value determine the process capability. So what we are simply saying here is that we need to adjust the improving process performance. To improve the process performance without changing the standard deviation, we need to adjust the process mean. We want the mean to be centered between the specification limits. So desired process mean should be upper specification plus the lower specification over 2. So the mean should be 28 millimeters. So the process mean adjustment should be 28 minus 28.6, meaning that the process mean needs to be reduced by the 0.6 millimeters. Okay, so this is it, what we are simply saying. So this mean of 28.6 should be reduced by 0.6, so 28.6 minus 0.6. So process mean should be just 28. Process mean should just be 28, so it should be reduced by 0.6. So you can find the process capability index using the CPK. So the minimum of upper specification minus the mean over 3 sigma. So again, upper specification minus the lower specification over 3 sigma. So here we are getting CPK equal to 1.25. So this is the new CPK, right? Using the adjusted mean, the mean that we have adjusted, which is giving us the same values here, so that we can have the same value using either the upper specification minus the process mean, or the process mean minus the lower specification over the 3 sigma. We are getting the same answers. So by adjusting the mean, so the mean needs to be adjusted, okay, without changing the standard deviation. So the mean should be reduced. Instead of the mean in the question, we had the mean of 28.6, the mean should be actually reduced to 28. So the mean should be 28 millimeters instead of 28. So mean should be 28 millimeters and not 28.6 millimeters. So this is how we are getting down to the answers, getting to the process capability, the CPK, which is the process capability ratio. So this one is called the process capability ratio. Okay, CPK is the ratio. So we are simply saying our CPK is equal to process capability ratio. Then CP is process capability index. Process capability index. Okay, so this is just about what we have concerning this assignment. So there is need just to go through the assignment paper. So another improvement here, we should just adjust the mean, where we are going to find the average of the upper specification and the lower specification divided by 2, which is to give us the mean of 28. And then finding the process capability ratio, process ratio, okay, is giving us 1.25, which is either the same here. So it's just giving us the same answer. The other side, either this one or using this other one, the answer is the same. So this is how this assignment came about. And when finding the proportion of meeting specification, we have to find the process capability index. So this is process capability index, CP, process capability index, which is upper specification minus the lower specification over the 6 sigma. So it's giving us the 1.258. Substituting it in this formula here, process meeting specifications is 1 minus that, which is 36.8%. So approximately 36.8% of the products will meet the specifications. So this actually marks the end of the review of this assignment paper. And question number 2 is just on types of cost of quality. We have the prevention cost, we have the appraisal cost, the internal failure and external, and just looking at the proportions, that is high, the prevention was high, followed by the external, then the appraisal, and then the internal failure was the least percentage in terms of the proportion of cost. All right, so this is a assignment review for the cost of quality. So the assignment review is done.